So I'm just going to explain the answer key. This is posted as well, but the way I want you to think of, if you see a shape like this where you kind of recognize the parts that make it up, but obviously we only have the formulas for, let's say, a hemisphere, okay? We have the formula for a cylinder, not half a cylinder, and we have the formula for a cone, but not half a cone, right? And remember, all of the formulas we are thinking of, none of them include this bottom here, the base. So if that had been something that we wanted to add, we would have actually kind of maybe turn this and look from the bottom and find those three pieces and add them as well, which would be a triangle, a rectangle, and a semicircle, right? So that's something that you could add. In this case, it's to be omitted. So I'm thinking, first and foremost, a hemisphere, not a sphere, half of a sphere, that's called a hemisphere, a cylinder, and a cone. Once I'm done adding all of these for the volume, I'll just split it in half, right? Or divide it by 2. And so I start, right? I put a big square bracket, leave the half on the outside. The hemisphere is 2 pi r cubed divided by 3. The cylinder is pi r squared times h plus pi r squared h divided by 3 for the cone. I insert the radius. It's everywhere, right? The radius stays the same for all of them. I have to find the height of my cone in this case. And so height, again, is one of the legs here. The hypotenuse is the 8. It's also the slant height. So I got to go hypotenuse squared minus leg squared. I get root of 39, and so this is the height of it. That is what I insert into my formula, right, when it comes to the height of the cone. And don't forget to divide by 3. That was a mistake I originally made. And so when you plug everything in, you enter that into your calculator and make sure you have these numbers readily available. You add them, right? You just go copy paste them and add. You get that, and then last but not least, I divide everything in by 2 or multiply it by 1/2, and I get this as my final answer if you used all decimals. And same with the surface area. Okay, so for surface area, again, I'm thinking of half, but I'm going to leave it outside for now. So it's surface area of the hemisphere, lateral surface area of the cylinder, lateral surface area of the cone. We do not want the 2 pi r squared that are involved with the cylinder, and we don't want the pi r squared that would be involved with a cone. We don't want the circles. They're not exposed surfaces, right? So we want to omit them. That's why it's just lateral surface area. So the formula really breaks down to this. And then you just plug in everything, again, just like before. Do this separately. Get these numbers, have them readily available, add them up. You get this. You divide everything by 2, and you get 329.87 as your final answer. So that is that. When it comes to the half cylinders that are kind of stacked like that, for volume is simply just adding the large, the medium, and the small. And remember, you have a half in front, because as you can tell, we're thinking of full cylinders. These are not spheres, right? There's no curvature like this going out or anything. These, if you think about them, they're cylinders. Okay, 3 cylinders stacked, half a cylinder to be specific. And so the trick here is to find the radius. And so my advice to you would be, if you want the further back, that's the one I would start with, the one that's at the back. Add up all the distances, right? 30 this way, and then it's 20 and 20, so this would be 40 and 30, that's 70. Another 40 going this way, that's 110. So the radius of the big cylinder at the back is 55. The radius of the middle piece, if you add everything up, you get 70, you get 35 for your radius, and the radius of the small one is 15. So for volume, it's just pi r squared times height, and notice that every single height of every cylinder is the same. But again, read carefully. You plug everything in, get the numbers, add them all up, divide it by 2, you get that as your volume. Okay. Then you have the total surface area of this. And so here you have to be somewhat careful. What I will do is I will find the entire surface area. Again, we'll split everything in half later on. Surface area of the large cylinder at the back. Then I'll just add the lateral surface area of the middle and the lateral surface area of the small cylinder. And this is why. If I find the surface area of the large cylinder, then I'm indeed, in finding the large, I'm actually finding all of this, okay? All of this part right here. It's kind of like the face of it, looking at it. And I'm also finding this piece right here, okay? And I'm also finding the front, okay? So in finding the total surface area of that back, I'm even finding the side, right? If I find the total surface area. So everything, and I'm finding the faces popping to the front. It's almost like if you could push this in, you would just get a flat piece like that. So really, just treat it like it's a flat piece, and you're indeed finding all of these 3 pieces right there. So that's what I do. And then lateral surface area of the middle, I just want that little ring on the outside and the little ring for the small cylinder there. And then it's just a matter of plugging everything in and being very careful how you compute that. Right, it's 2 pi r squared plus 2 pi r h plus 2 pi r h of the medium plus 2 pi r h of the small. And I add everything up, and I end up with 25,000 and some. Divide that in half, you get 12,199. If the bottom were to be included, like if you were to dig under here, right, there's 3 rectangles, right? 3 rectangles. This would be the back, the middle, and the small one. And it's fairly simple to figure out their dimensions, and I just do it right here. You were to add up those areas, and so all the bases combined plus the previous surface area, you would get a total of this many square feet. So that hopefully explains these pages. Next up will be the truncated cone, if they're cut off, so you'll be able to work with that. All right, thank you.